This is the first question. Show by calculation that the roots of x squared positive 2x negative 5 equal to 0 or negative 1 plus or minus root of 6. So let us start by considering x squared positive 2x negative 5 is equal to 0. So we will use the quadratic formula. So what is the quadratic formula? X is equal to negative b plus or minus root of b squared negative 4ac divided by 2a, where a is equal to coefficient of x squared is 1, coefficient of x is b, coefficient of the constant term is c. So you substitute the value negative of 2 plus or minus root of 2 squared, 4 is 4 times a is 1, c is negative 5 divided by 2 times of a is 1. So this is equal to negative 2 plus or minus root of 2 squared is 4, negative negative positive, 4 5s are 20 divided by 2. So this is going to be negative 2 plus or minus root of 4 added to 20 will give me 24 divided by 2. I can rewrite 24 as 6 times 4 divided by 2, which is negative 2 plus or minus. I can rewrite this as root of 6 times the root of 4 divided by 2, which is going to be negative 2 plus or minus root of 4 is 2 times the root of 6 divided by 2. So 2, these can be cancelled, giving me negative 2. In fact, negative 2 is already gone because I have cancelled. So it's going to be negative 1 plus or minus root of 6. So therefore x1 is equal to negative 1 plus root 6 and x2 is equal to negative 1 negative root 6. So these are the roots. Now I'm going to show you the check. Negative 1 plus root 6 and negative 1 negative root 6 are the roots, right? So this means x negative of negative 1 positive root of 6 and x negative of negative 1 negative root of 6 are factors. So this means x negative of negative 1 positive root 6 multiplied with x negative of negative 1 negative root 6. When you multiply them, they are equated to 0. This is rewritten as negative or negative is positive 1. This is going to be negative root 6 times x negative or negative is positive 1, and this is positive root 6. Okay, is equal to 0. Now a negative b times a positive b is going to be a squared negative b squared. So this is going to be x positive 1 the whole squared negative root of 6 whole squared is equal to 0. This is going to be x squared positive 2x positive 1. Root of 6 whole squared is going to be 6 is equal to 0. So you add these two, you get x squared positive 2x negative positive 1 negative 6 is going to be negative 5 is equal to 0. So this is exactly the question given. This is exactly the equation given. Okay, here x squared positive 2x negative 5. Hence the check is verified. Okay, now you don't have to do this. Now this has been done for your understanding. It's an extra information. Okay, your work stops right here in the minute you have zeroed in the roots. Okay, let's move on to the next one. Now this is the next question. They are asking us, hence solve the simultaneous system. 2 positive x is equal to y and xy is equal to 5. So this is the second part of the question. Now let me consider x positive 2 is equal to y and xy is equal to 5. What I'm going to do is I'm going to say put x positive 2 is equal to y in 2. We get, in place of y I substitute x positive 2 is equal to 5. So I get x squared positive 2x is equal to 5, which means x squared positive 2x negative 5 is equal to 0. We have already solved it. and we have got x is equal to negative 1 plus root 6 and x is equal to negative 1 negative root 6. Now when x is equal to negative 1 positive root 6, we have to find the value of y. So for that I'm going to substitute it in put it in 1, we get, so negative 1 positive root 6 positive 2 is equal to y. So y is equal to, you add these two, you get 1 positive root 6. Now when x is equal to negative 1 negative root 6, we get y to be equal to negative 1 negative root 6 positive 2. We add this, we get 1 negative root 6 is the value of y. So therefore the coordinates are, when x is negative 1 positive root 6, the value of y is positive 1 positive root 6, and when x is negative 1 negative root 6, the value of y is 1 negative root 6. Okay, right. Now we are actually given to complete this table, y is equal to 2 raised to the power of x. Now this is the table we have been given. So we got x and y, negative 1, 0, 1, 2, 3 and 4. So we need to fill in these values. Now when x is equal to negative 1, what happens to y? Y is equal to 2 raised to the power of negative 1, which is nothing but 1 over 2. So 1 over 2 goes there. Now when x is equal to 0, y is equal to 2 raised to the power of 0, which is nothing but 1. This is already given. Now when x is equal to 1, y is 2 raised to the power of 1, which is nothing but 2. And x is equal to 2, y is 2 raised to the power of 2, which is 4. And x is equal to 3, y is equal to 8. This is given. And x is equal to 4, y is 2 raised to the power of 4, which is nothing but 16. So we have completed the table. That answers the question. Now we have to draw the graph. Okay, we have to draw the graph for y is equal to 2 raised to the power of x. So that's exactly what I'm going to do here. Now the graph is going to be on the positive axis of x, and also for y, so it's not going to come down. So that's the reason I am taking this far below. So this is my y-axis, this is my x-axis. The points are 0, 1, 2, 3, 4, 5 and 6. The points for y are, I'm going to take it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now you can write the scale here. X-axis 1 centimeter is equal to 1 unit. Y-axis 1 centimeter is equal to 1 unit. Now for all graphs, writing the scale is imperative, is necessary. Okay, now there is one point the graph is actually moving in the negative side, which is over here, negative 1. There is one particular point, but still it is on the upper half. Okay, it does not come down. So when x is negative 1, the value of y is 0.5. When x is negative 1, value of y 0.5. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. 8 is over here. When x is 4, it's 16. So it goes up all the way here. So I have to mark it. if I were to increase this up, it's going to be 12, 13, 14, 15 and 16. 4, 16. Oh yeah, so if you were to draw the graph would be flowing like this. Okay, so if this point is somewhere over here, okay, 16. It's not to scale, okay, this is just an approximate simulation, but this is the curvy nature of the graph will be y is equal to 2 raised to the power of x. Okay, fair enough. Now they are asking us to find a value. Okay, find a value for, let me take another sheet. You're asked to solve 2 raised to the power of x is equal to L is equal to 11. Find the value of x and draw the graph. Okay, now what I wish to do is I will take log both sides, log to the base 10 both sides. So it's going to be log 2 raised to the power of x to the base 10 is equal to log 11 to the base 10. Now there's a formula, log a raised to the power of b is b times log a. So it's going to be x times log 2 to the base 10 is equal to log 11 to the base 10. Therefore x is equal to log 11 to the base 10 divided by log 2 to the base 10, which is equal to, use your calculator. So log 11 is 1.0414. I'm going to take it as 4 places out of decimal, and log 2, this is 0.3010. fair enough. Now 1.0414 divided by 0.3010, that is equal to, approximately equal to 3.459. I'm going to make it as 3.46. Okay, so go to the graph. 3.5 is over here. This is an approximate point. So what do? You have to go here. You have to make the connection at 11, right? Y is 11, and you drop the line. This is an approximate. You drop the line. And you mark it as 3.446. You make it as 3.5. Okay, round it up. But ensure that you plot this on the graph sheet. You would be able to do it with much accuracy. So this point is 11. Okay, so that is the solution for this question. We can move on now.